Okay, so let's look at deriving sin A plus B equals sin A cos B plus cos A sin B. Now, disclaimer, this one is one of the strangest ones to derive and probably one of the hardest. So in order to do this, you need to have some pre-existing knowledge, and the pre-existing knowledge you need to have is this formula here and this formula here. Now, what I'll say is you can get away with just knowing them and continuing on, but I'm going to spend about a minute here in the video just talking through kind of where these come from. You do not need to derive this for the Leaving Cert course. So effectively, you can do this by just looking at, this is a sine wave, okay, going from 0 up to 360 and going back to minus 360. Similarly, this is a cosine wave going from 0 to 360 and back to minus 360. And I find the easiest way to do this is to even use your calculator if you want, although you don't need to, but to set it up so that you can see the relationship between them. So, for example, sine of 180, right? Here we can see this is a sine wave. Sine of 180 gives us a value of 0. To get the equivalent of that, you could do cos of 90 minus 180. So if I start at 90 and I go back 180, you can see that I get cos of minus 90, which is the same as this guy. You can test this for any value. So for example, if I do sine of 270, sine of 270 is minus 1 down here. So go over to here and say, okay, what's 90 minus 270? So 90 minus 270, counting back, would bring me to here, which is also minus 1. So these guys have the equivalent value. Similarly, down at the bottom here, I can say for cos A, it would be the same as sine of 90 minus A. So let's just say we do cos of 90 for argument's sake. That would be the same as saying sine of 90 minus 90, which would be sine of 0. Check sine of 0, and sure enough, we get the same value. Okay, you can do this anywhere. Let's just do the last one. If I say cos of 360, that would be the same as saying sine of 90 minus 360, which would be minus 270. So this guy would correspond to minus 270. And sure enough, they do, because this is a value of 1, and this guy also has a value of 1. Okay. In essence, though, you only need these two rules going forward. So I will copy paste them now for myself. Now, the last thing we need to really tackle this rule is going to be one of our previous rules that we did of, and I'll put it in blue. In our formula booklet here, we're going to utilize this rule that we had earlier of cos A minus B. So with that, we now have all the tools we need to get going. So how's this going to work? Well, what we're going to do is we're going to replace all of the A's here with cos, or with 90 minus A. Okay, now this may seem a bit obscure, but just follow it through. So we're going to get cos of 90 minus A minus B equals cos of 90 minus A cos B plus sine of 90 minus A sine B. Now, in our next stage, let's kind of clean this up a bit. We're going to say, I'm going to just do a little fancy thing with the brackets here. What I'm going to do is I'm going to remove the brackets. So I'm just going to say 90 minus A minus B. You might say, Steve, why are you doing this? Or I could have done that in the first place. Absolutely. And we know from before that cos of 90 minus A is the same as sine A. So I'm just going to replace this in saying sine A. Now, it's really important that somewhere in the page you put this down for the examiner. Okay. Just to draw attention to it. So it's sine A cos B. And similarly, if I go over to here, sine of 90 minus A is the same as cos A. So I'm going to say cosine A, sine B. And we're nearly done there. The last thing we're going to do on the left-hand side is I'm going to put a bracket on this guy, like so. So notice how I've taken the minus out and done it by A plus B. Now, again, this is this rule sneaking in again, because if you take a look, it's 90 minus a symbol A here, but if I call this A, for example, it's 90 minus A, which would make it sine A. But effectively here, what I'm doing is I'm making it sine A plus B, because this whole thing, 90 minus A, pretend this is just the letter A, then that would become sine A. But instead of being just A, it's going to be sine A plus B. And it's quite a leap. It's quite redonkulous, no doubt in that. But realistically, it all comes down to these two little rules and being thrown into your cos A minus B. And that's it there for your derivation of sine of a plus b. Hope you found that useful. If you did, then like or subscribe, or check out the other social medias where I'll be adding extra resources. If you want something particular made, then just leave me a message on one of those platforms and I'll do my best to get around to it at some point. Best of luck in all your exams.